Hello there, and welcome to the Bitcoin Takeover podcast. I am Vlad, and this is season 15, episode 36, if I'm not mistaken. And I'm here live on both Twitter and YouTube. Thank you guys for watching with Eli Ben-Sasson, who is an academic cryptographer and mathematician who has quite a few interesting research papers, who spoke about Bitcoin at conferences around 2013. You can find online video of that. He's also a co-founder of Zcash, and you can see a pattern in his interest that he's very much into researching zero-knowledge proofs, because right now he is the co-founder and also has a position. I don't want to say the wrong position, so I'm not going to mention it. I'm gonna let you, Ellie, say it. So you are the co-founder of StarkWare, and that one is also dealing with zero-knowledge proofs. You created STARKs, which sound a lot like SNARKs, and I think that's a good starting point to define the terms and understand what this is all about. And I think it's a very avant-garde conversation about privacy and data compression and how you can make stuff scale. So thank you very much for being here, Ellie.
Thank you, Vlad. Always happy to talk to Bitcoin enthusiasts. Yeah, looking forward to this conversation.
Right, so I think the best starting point actually is, what is a zero-knowledge proof?
So a zero-knowledge proof is a proof in which you learn that a statement is correct without knowing anything about the witness and side data that went into it. So zero knowledge is very much a privacy-related technology. For instance, I can prove to you that my age is over 21 without sharing my ID with you and stuff like that. However, there are other aspects of cryptographic proofs that are often termed ZK proofs that deal with something completely different, which is very fast verification of the integrity of a computation. So there are like two different aspects to zero-knowledge proofs. People are usually more attached to the privacy aspect, and I think my co-authors on the Zero Cash paper and co-founders on Zcash and I have some of the blame for that, because the way these proofs were first popularized was through the privacy angle and the zero-knowledge aspect, but there's also a succinctness and scalability aspect to them, in which they can speed up computation or speed up the verification of the correctness of a computation. And we'll talk about both aspects, the privacy and the scalability.
Yes, I do recall sitting at a table with a couple of Bitcoin core developers, and one of them, who right now is a maintainer, her name is Gloria Zhao, was super excited about the idea that one day you will be able to synchronize a Bitcoin full node just by storing this zero-knowledge proof that verifies that all of the transactions that came before are in fact correct. And this can take maybe less than 1 second to synchronize. And furthermore, there is very little computation involved, so you can do it from a mobile phone.
Yes, this very statement and very vision was first. I was the first to articulate it and present it roughly 11 years ago, almost to the day, in May of 2013 at the Bitcoin conference in San Jose. My talk there is still on YouTube, and I was an academic researcher. And one of the things I said on the podium, to an audience that included Greg Maxwell and Mike Hearn and a bunch of others, was that one day when you fire up your Bitcoin node, instead of going through all blocks from Genesis and verifying each transaction, you will download a proof and verify it. It's going to be less than 1 MB long, and you will verify it in less than a second on your laptop. And yes, this promise is still something that has not yet been fulfilled, but is very close to being fulfilled, and technologically it's very doable.
Yeah, I was going to ask you how far away are we from this vision? Because you mentioned this 11 years ago on stage. I think the research into zero knowledge proofs has been much better funded since then, but for some reason we're not there yet. And I was curious what it takes for us to get to the point where we can have this type of verification of hundreds of gigabytes of data in just 1 second.
So we already have this very thing existing. You can already verify hundreds of gigabytes of data in less than a second. And this is already something that we have been, when I say we, I mean StarkWare, the company that I co-founded and I'm the CEO of today, has already been doing in production since the summer of 2020. So for roughly 4 years, this has been running in all our products. It has not been running on Bitcoin, not because the technology cannot work there. It can. So we, in terms of, there are computers and there is the technology today to verify, to generate the proof that would prove the correctness of all of the blocks of Bitcoin from the start to end. The only thing preventing this being done for real is the engineering to put a system that is dedicated to Bitcoin. And the reason for that is actually very simple. As when we look at StarkWare and elsewhere at can Bitcoin, once you generated this proof, will it be consumed by Bitcoin nodes? Will it be part of the consensus? Will it be something that indeed is part of the protocol? And the answer to that is that today, the answer is still no. I think with things like introducing OPCAT, we will get much closer to that, and we'll talk about it. So it's really not about, the technology is out there, and the readiness is out there. It's more a question of, is the Bitcoin community and then also Bitcoin consensus interested and willing in allowing the implementation of a Stark verifier on Bitcoin nodes? If you say yes, I promise you, if Bitcoin says yes, I promise you that tomorrow, a lot of the engineering resources and StarkWare and other places in Starknet will be dedicated to doing this very thing that I spoke about 11 years ago.
That would be super cool. Personally, you have my vote, but you know how it is with Bitcoin. You need a very rough consensus, and it's hard to
Yes.
get there. I think we are culturally stuck at this point, and some people even argue that Bitcoin is just good enough and we don't need anything else. And that's the reason why I still do this podcast. I present new ideas and benefits to adding some opcodes into Bitcoin. And I wasn't expecting to be talking about Opcat today. That opcode in particular was written by Satoshi Nakamoto. It was rewritten in its current
Right.
form, in which it was proposed, if I'm not mistaken, if it was BIP 69420 or something. No, it was 420 because it was proposed on the 20th of April.
Mm-hmm.
And it was rewritten entirely to be restricted in the stuff that it can do. And yeah, I see that someone dropped out and your video is no longer visible in my feed, but it's fine. So what is Opcat and why do you think that Bitcoin needs covenants?
Oh, so first of all, I'm an admirer and consumer of Bitcoin, but I don't feel qualified enough to talk about all the amazing aspects of covenants or even OPCAT. There are others more qualified, Ethan Haleman, Andrew Polstra, the Blockstream folks. There are a lot of people that have a lot more state on that. From what I understand, the existence of OPCAT will allow simpler and more efficient verification of STARKs on Bitcoin. And this may open the door to having things like layer twos or all kinds of, self-custodial bridges available on Bitcoin, which I think would be a good thing. I have a lot of respect for Bitcoin and also the conservative mindset that supports it. I think that, generally conservatism is something that I have a lot of respect for, and I understand, right? That these are very complex social systems that we understand very little. So I don't feel comfortable enough even advocating for, the speed at which it should be adopted. What I can say, so my Twitter handle defines me as a Stark Maxi. So I very much believe that ZK Starks, the technology I co-invented and which now is the gold standard for scaling in a future-proof way blockchains, and it's adopted by nearly all projects who work on this topic. I strongly believe that it is really, really important for human society. And since I think Bitcoin is one of the things really needed in free society today and on an ongoing basis, and it's needed to fix a lot of the wrong things that are out there today in our computerized world, I really hope that Bitcoin, with all its conservatism, is convinced to see the power and the alignment of technologies with ZK Starks and allow its adoption. And I understand that OPCAT is one such way in which it can be adopted. So I think that would be good.
I was going to ask you if you see any difference between OPCAT and OPCTV, which is the other popular proposal for covenants. Do you think that CAT is more powerful and enables more functions?
I don't know enough about CAT versus CTV to give an informed answer. Sorry.
For me, as someone who spends most of his day reading Bitcoin debates, it's apparent that CTV has more support, but OPCAT has support from more vocal people. So it's going to be interesting which one we're going to get, or if we're going to get one at all. But I do hope that we're going to extend the functionality because there is so much more that you can do with these covenants. You can do trust minimized sidechains. You can do so many cool bridges and all sorts of stuff that right now is just purely theoretical. But I was going to ask you, what's the difference between SNARKs and STARKs?
So I would first of all say that it's a little bit like a Venn diagram, meaning that you have like there are two mathematical definitions, and some things they fall in the intersection. So first of all, maybe let's start with a SNARK. What is important about a SNARK is that the verification be very short, very succinct, and that the whole verification of the proof basically involves just one message. Proof is one message, and there is no interaction. There is no the way you verify it does not allow you to post the first part of a proof and then a second part of the proof. As you would do, let's say, when I try to prove to you something, sometimes I would do it in an interactive way. I would say something, you may ask me a question, I would say another thing, and we'd go back and forth a little bit. So according to the definition of SNARK, that is not allowed. That's the letter N in the SNARK. It means non-interactive. At the same time, it allows you to do things like a toxic waste involving a setup phase in which some secret key that can ruin everything if it's revealed is baked into the protocol. So it allows these processes, and it even allows these processes to be as long as the computation then being proved. So it allows like this initial non-succinct and highly toxic and scary part to be done. So that's what a SNARK is. The definition of STARK says that you should have the succinctness as in a SNARK, but you need something additional. Well, you need two additional things. One is that the time needed to generate the proof must be pretty much nearly linear in the computation size. And also, the verification time must be exponentially shorter than the time needed to compute. At the same time, the letter T in Stark means no trusted setup, no secrets. Everything must be done completely in the public. It stands for the word transparent. So what happens is that, oh, and another thing that Starks allow you, and we'll get to this because of like the proof of work and of Bitcoin is a very interesting case where this may actually be very beneficial. Starks do allow you to have a proof which is a little bit interactive, where there's a little bit of back and forth. So now, just going back to this Venn diagram, there are many things that are both a Stark and a SNARK, but there are some things that are not a SNARK, and there are some things that are not a Stark. So most of the proof systems used for privacy purposes with very short proofs, for instance, on Zcash, are SNARKs that are not Starks because they have a trusted setup aspect to them, okay? So things like KZG commitments, Groth 16, the Planck protocol, those are SNARKs that are not Starks because they require a trusted setup. They are also prone to attacks by quantum computers and involve a lot of number theoretic assumptions that you know I feel less comfortable with. There are Starks that are not SNARKs. For instance, if we're going to deploy a Stark system on Bitcoin in which you first commit to something, you wait for the next block, you get the block header, and using that, you answer some queries, which is a very interesting and safer and more efficient form of a Stark proof. You will have a Stark that is not a SNARK. But then there are many things like the things we deploy today on Ethereum are both Starks and SNARKs because we sort of use the fiat Shamir heuristic and get one thing that is both transparent but also non-interactive. There's like just one proof being sent out there.
Yeah.
I'm pretty sure I confused the listeners more than I made it clear. But I should say this, anything that is a Stark, you can easily convert it into a SNARK. In the other way, it's not as simple.
It almost sounded like poetry. It rhymes a bit, Starks and Snarks. Not everything that is a Stark is a Snark, but some stuff that is a Snark is a Stark. It sounds like this.
Yeah. Well, it was on purpose. I coined the term Stark. I was already, deeply involved in Snark research, and I liked the sound of it. I was also reading Game of Thrones at the time, and and I was looking for something that is a little bit different. So that's how the Stark term came around.
Yeah, and I also want to mention that this podcast is sponsored by a company that's called ZK Snacks, which is, I guess, a way of making fun of the whole ZK stuff. But their product is Wasabi Wallet, and I guess it's also fun to use it because if you don't want your spouse to know how much Bitcoin you have, or you want to do all sort of mixing for purposes which concern your own privacy, it's the most advanced technology that there is right now. It's also made by, it's designed by a cryptographer from Israel, very brilliant guy. His name is Nothing Much on Twitter if you want to follow him. And yeah, very bright guy. He designed this Wabi Sabi protocol. And what you can do after you mix, because there's a lot of FUD about coin joins, is that there's a buy anything button on the top of the wallet. And you can use that interface to order anything you want and you pay with your Bitcoin. You just say where you want it delivered, and it's a very useful tool for whatever you may need. You can order pretty much anything that's legal in Poland. That's the answer to the limits of what you can order. So check out Wasabi Wallet at wasabiwallet.io. And now that we got over this ad, I want to ask you, why did you decide to create StarkWare? What does it do?
So I started as an academic researcher. I was doing math and computer science, theoretical computer science for 25 years. Um, um, at a bunch of research institutes and places. And I was very happy as a professor of theoretical computer science. But StarkWare was founded in 2018, and one decade earlier, in 2008, I started being involved in implementing these cryptographic proofs, things based on what's called the PCP theorem, the probabilistically checkable proof theorem, for those of the listeners who studied theoretical computer science, which led to presenting this research at the Bitcoin conference in San Jose, 11 years ago. And that was for me the moment I was red-pilled for Bitcoin and blockchain in general. So starting 2013, I started more and more shifting my research towards showing how these very theoretical constructions could be applied to the world of Bitcoin and other blockchains. And I had like three attempts over the years. So the first was the Zcash. We wrote an academic paper, the Zero Cash paper, about, it's titled Zero Cash, something like adding privacy over Bitcoin, or privacy over Bitcoin. And what happened was that, sadly, we realized that getting this on Bitcoin would involve a lot of politics and social consensus, and it wasn't possible back then. And 11 years out, it still is not possible to do a Zcash transaction on Bitcoin. I think that there's both the general just Bitcoin conservatism politics, but there's also the aspect of using one of those toxic waste-based SNARKs that is very much not in line with what Bitcoin is about. So I co-founded a company, Zcash, to create the Zcash cryptocurrency. I also tried to commercialize the technology in another way, but we ended up tried that for a year and a half and didn't go anywhere. So we sort of closed that effort. And then in 2018, thanks to some math breakthroughs, specifically things like the Fry protocol and the Stark protocol, I realized that it's a good time to try commercialize it again. So StarkWare was the attempt to commercialize the scalability aspects of ZK proofs. So everyone today talks about how ZK rollups are the end game for scaling blockchains. But the very first to say this, not just say this, but actually found a company around it, was StarkWare. So we, back in 2018, said ZK Starks are the way not just for privacy, they are the way also to scale blockchains without any change to the core principles of blockchains. So that's why in 2018, I co-founded StarkWare.
Yeah, I was going to ask you, what do you think happened to Zcash? Because I remember there was a lot of hype surrounding it. And I think there still is. They're doing some very interesting stuff with the Halo 2 protocol and stuff like this, but it didn't get much traction among users. And it seems like the privacy-oriented guys seem to prefer Monero, even if it scales much more poorly. And
Yeah, not just scales more.
I want to mention this on live stream that I own Peter Todd's laptop from, it says here, non-electronic remains of compute node. And this was used to create the private keys for the first Zcash ceremony, of which Edward Snowden was also part.
Yeah. So first of all, congrats on owning a relic from this very important ceremony. It was the first, trusted ceremony. There's a very nice, I think NPR or Radio Labs episode about it. Really, really cool stuff. This is exactly the ceremony that generates the proving and verification keys for Zcash, which is exactly the kind of stuff that you don't need anymore with protocols that are transparent, with things like STARKs and also like Halo and Halo 2. But still, it's really cool that you have this. So you're asking what happened to Zcash? I think it's probably that the UX and UI aspects of dealing with SNARK proofs is just some barrier that is very hard to overcome. So end users, for them to do a shielded transaction today on Zcash is still something that is even much harder in terms of UX and UI than it is to use whatever, a Ledger or a Trezor or any one of the existing wallets on Bitcoin. And I think that's the main reason that because we all need privacy to our financial transactions. It's just that the UX and UI are very hard to get right.
Well, I do think that Zcash created some interesting research and started the conversation around zero knowledge proofs.
Yes.
Because after Zcash emerged, I think some of the benefits of data compression from zero knowledge proofs were researched on, and Ethereum discovered that they need this to be able to reach the vision and the scale of the project that they want. And then some people came along and they said, we can actually insert zero knowledge proofs into the Bitcoin blockchain and verify against that. And that's how stuff like Citrea and Build on Bitcoin came around. And it's very avant-garde. I was going to mention that the conventional way to scale that has been proposed was to use sidechains. And sidechains have been a holy grail in terms of making them trust minimized or trustless. But the ZK stuff and all of this rollup stuff appears to be the alternative, which is much more scalable.
I agree. And as I said, probably most of your listeners don't know this, but what is now considered the gold standard is something that, StarkWare and I personally have advanced in our work and in our company and in our talks. So I've been talking about this since 2013. StarkWare has been at it since 2018. And I'm very happy to see that today this is the consensus. I'll tell you this, both in my academic career and then also as an entrepreneur, it's been a lot of walking in the desert and, spreading the word and spreading the gospel. And it's an enjoyment to see now that this has become, the gold standard and everyone accepts it. It's not just the particular, it's not just the general use of ZK and validity proofs to scale blockchains. It's also the particular technology that we invented, the Stark protocols that are, for instance, post-quantum secure. So even if you tomorrow have a quantum computer, they will not be broken. And this sort of future-proofness of the technology, the lack of any trusted setup or any trust assumptions about the parties starting or building the protocol is really, really crucial and very much aligns with what Bitcoin is about, right? So this particular technology, the Stark technology, and the more general way of scaling blockchains using validity proofs is really something that we're very proud of initiating.
I think this is also a conversation that deserves to be had about quantum computers and to which extent they pose a threat to existing blockchains, and whether or not they will be able to brute force a private key from the public key in the next 20 years or something. Do you believe it's feasible?
The way I would go about it is to say, if you have an alternative that is safer, why risk it? So I don't know if there will be if a quantum computer will be able to break, let's say, Bitcoin in the next 20 years. But I do know that there is a way to replace both signatures and scalability solutions with Stark-based methods that would mean that if there is a quantum computer, then nothing breaks. So because you can get, for instance, you can get digital signatures that are post-quantum secure based on Stark technology, and you can aggregate them very, very efficiently using recursive Starks. And you can also scale Bitcoin much better without any break of its core principles using Starks. So if you have a technology that is essentially ready for use and would also protect you if there ever is a quantum computer, I would say you want to try and use it. And then you don't have to worry about whether there will be a quantum computer out there or whether some breakthroughs regarding factoring of numbers will emerge, because a lot of the leading mathematicians do believe that you can factor. I mean, we don't know how to do it yet, but they would actually take sides with a claim or with a assumption that you can factor numbers in polynomial time. So for instance, the famous number theorist Peter Sarnak, I know, holds this point of view. I also believe that we will be able to factor in polynomial time, or certainly much better than we can today, integers in our lifetime. So even if there's no quantum computer, you could still have those systems broken. So why risk it?
Yeah, I think this conversation is usually classified as FUD, and people say, no, it's not going to happen. Quantum computers are still very much theoretical, and they don't accomplish much. But I guess I agree with you to the degree that we should be ready for any sort of threat and should be proactive as opposed to being reactive to prevent the threat from even emerging in the first place.
The nice thing is that in the case of Starks, you get other, like there are enough good reasons to want to use them that are related already to scaling. You can scale, you can with the amount of computation needed to verify a block on Bitcoin, you can today spend the same amount of computation or even less and verify 1,000 times more transactions or 1,000,000 times more transactions. And this is not something theoretical. This is something that is done on a daily basis on the StarkX systems and on Starknet, which are existing, L2s. They're currently layer 2s on Ethereum, but I'd love to see them deployed on Bitcoin if Bitcoin would allow this. So it's not just that you get better protection against attacks, quantum computers, or innovations on factoring numbers. You also get benefits today, even if you never have any improvement on the factoring capabilities through classical or quantum computers.
Yeah, and I think right now there is a resurgence of the block size debate in Bitcoin, and people say, we could still be decentralized if we had just slightly larger blocks. But on the other hand, we seem to be having this situation where, with the emergence of zero knowledge proofs, we discover ways in which we can make transaction sizes smaller. So you don't need to increase the block size, you just need to use the block space more efficiently. And do you believe that these zero knowledge proofs can, in the future, maintain this 1 megabyte block size while making transaction sizes much smaller?
Yeah, not just in the future. If like Bitcoin would allow an OP Stark or Stark verification, which to verify Stark, all you need is to verify paths in a Merkle tree. But a very small number of them, and then allow a very small number of multiplications and additions modulo a small number, like a 32-bit integer. So if you would allow those two things to be done efficiently on Bitcoin, and these are things that all of our computers do, like within milliseconds, millions of times every day, and they're very safe, you would have, again, 1,000-fold increase immediately in the TPS without any change to the block size. Now, since we're talking about block size, again, as someone outside of Bitcoin, I think that here the conservatism has gone just a little bit too much in the following sense. There's a general, whether you believe in Moore's law or in just observe the reality, you see that like throughput and storage and communication bandwidth, they're still growing and rising, which means that I think if Satoshi were still speaking, Satoshi would say, look, it makes sense to allow a moderate increase in things like throughput and block size and things like that, that would be in line with the increase in all these technologies. So if you look back at 2008 and look at things like whatever, how much storage you could get for 1 cent or how much bandwidth could you get in 1 second, probably each one of them has gone up by 10-fold, maybe 100-fold. So if Satoshi were around, I believe he would have said, or she would have said, or they would have said, let's match that with our capacity. But I'm pretty sure Satoshi would have also wanted Stark verification on Bitcoin. I certainly know that people like Greg Maxwell and Mike Hearn and Gavin Andreessen and others definitely wanted it when they were active in this space. And I know that people like Andrew Polstra and Ethan Haleman, Peter Willey, I think they're also supportive of it. So
yeah, it's just the culture that changed. I think the developers are very much in favor of this. But I actually got a question from Robin Linus, who is the creator of BitVM. And I think that's the most exciting breakthrough that we've had in Bitcoin in a long time because it's permissionless. He just put it on top and said, use this to build cool stuff. And he told me, ask him about data availability of the state differences.
Right. It's a very good question. So let me just first of all explain so all the listeners understand what we're talking about. Suppose even that tomorrow, let's imagine a world in which you had, so everything costs nothing. What do I mean? Bitcoin has added an OP Stark. And additionally, the time to verify a proof is 0. And additionally, the length of the proof is 0. Okay. Could you now scale things infinitely? And what is the problem of data availability? In the end, you have like the UTXO set, right? And suppose there were 1 million transactions, a million or 1 billion transactions. So whatever started, the UTXO set before these 1 billion transactions, you now have to apply a state diff, right? To move to this new UTXO set, right? After these billion transactions. And the question is, just in terms of the amount of data, won't this be more than 1 megabyte? Okay, so the answer to that is yes, probably would have been much more than 1 megabyte. However, there's some caveats to that, and there are also some alternative solutions. So the first is that if, for instance, you would have many transactions that deal with the same start and end states, then even if you had 1 billion transactions or 1 trillion transactions, the state diff wouldn't be large, right? The state diff would just be the number of, the number of UTXOs that are now invalid and the number of new UTXOs that are now valid. So just to take an extreme case, suppose Alice pays, starts doing this chain of payments that is of length 1 billion. So you would have a Stark proof covering the integrity of these 1 billion transactions, but the state diff would just cancel, right? The very first transaction, and then put in the very, one, just state diff would have just 1 UTXO difference, okay? So that's answer number 1. However, realistically, if you allow, let's say, 1 billion transactions in each block, probably the UTXO set will involve many addresses. I don't know, maybe 1 million. So this, first of all, goes back to my general recommendation that says that since things have increased in terms of speed and scale and bandwidth since 2008, I think it's reasonable to have some moderate increase in size. But the other way to get around it is to allow alternative data availability modes. So one thing that we've been using again in production in our systems for more than 4 years now, sorry, close to 4 years, is this thing called Validium, which means basically you allow your users to decide if they want, let's say, the UTXO security, which means they're going to need to pay to be one of the things that that all of the miners of the world know, or whether they're willing to go with something that has less security because it will be maintained by a separate set of, or a smaller set with lesser security of nodes that can be remunerated by different means. But they will also pay much less because the amount of space won't be 1 MB, it will be, I don't know, 1 GB or 1 TB or whatever it is that those nodes are willing to do. So, and I think, when I buy my house, or from let's say, a day trader, then let's say maybe once a day I go back and record things on the blockchain. But through my day-to-day interactions, maybe I'll be fine putting some of them on a Validium. But it's a very good question by Robin, which doesn't surprise me because he's a very smart and knowledgeable person on these matters.
I'm giggling right now. First of all, because I'm happy about the topics being discussed, and secondly, because we were on this Telegram chat setting up the interview, and I think it was the marketing person who asked me what's my target audience, and I said I have a lot of nerds listening to this. This is my target audience. These are the people who listen to the show, and I'm very proud of what they do.
Yeah, they're really amazing.
Thank you very much for this. I feel like I need to rewatch this and think about it once again, because these are issues that I haven't even considered before. And I think my camera is frozen, so let me ask you another question and I'll fix it while you answer. So I was looking at the website of StarkWare, and I realized that it's a much bigger deal than I thought. All the big names in the industry have invested in this. And Robin told me that Starks and SNARKs are the future of everything for scalability. So how did you manage to pull this off? Because technologically it's sound, but it seems like financially it's also incredible. And I guess now I'm channeling the CEO side of you.
I mean, I read from time to time all these threads about how horrible it is to be a founder and how horrible it is to be a CEO. And it's like, I was just responding to some tweet on Friday that says that like founding a company is like jumping off a cliff with parts of an airplane and building it in mid-flight. And I remember seeing some video of Elon Musk saying that like being a founder or a CEO is like chewing glass and constantly fearing death. My view and my experience has been very different. It's been pure joy. First and foremost, because we've managed to attract an amazing team of, you mentioned the nerds, amazing gigabrains, both in StarkWare and in the Starknet ecosystem, that have been aligned on this vision. And what is this vision? It's also the vision of Bitcoin. It's a very simple vision. The vision is that integrity should never be assumed. It should always be demonstrated publicly for all to verify. That's the vision. And what we realized early on is that we have a technology that is a perfect fit for this vision. And it's a vision that's much bigger than any one particular blockchain. And those working at StarkWare and working within the Starknet ecosystem are very brave and courageous and believe in this vision. But I think it's a little bit like Bitcoin, right? Bitcoin, people walked the desert for many years with conviction. I certainly have, all of my academic career has been, the sort of taking things in theory and making them practical I know because my academic friends have told me that behind my back they were saying, why is he wasting, this decade on this ridiculous stuff of like taking some math theorems and turning them into code. And certainly when StarkWare was founded, there were many people who were saying, well, scaling isn't really a problem. And if it is a problem, the solution is not going to be Starks. And it's certainly not going to be the particular version of technology that you're advocating for. And I think by now there's consensus that the way we've been advocating for is actually the best way to solve the problem, and it'll also be the one to solve it first. Um, Luckily, you mentioned like some of the teams that have been backing us, and luckily, the space abounds with people who are very courageous and visionary. I mean, that's blockchain for you. So it wasn't that hard in hindsight. It was the conviction and the vision, and I think it resonated with people who have an open mind and are willing to go for a long while to achieve their vision.
One of this show's sponsors is Layer 2 Labs, and Paul Stortz has been working on this Drivechain idea for a long time. I'm just a tiny window right now. I'm gonna fix this. So much stuff that went south during this interview. But he has this idea of building a sidechain for everything on Bitcoin and making it trust minimized to the extent that miners protect it. And I was going to ask you, do you believe that Opcode is enough to bring Starks to Bitcoin, or do you think that having this sidechain would bring more functionality?
I think that Opcat, from what I understand, is the bare minimum that would allow you to just sneak through the door and get something. But this something would be, you can get a lot more by allowing a few other things that I don't think would break with Satoshi's vision. Some of them were already allowed, like an OP for multiplication or modular multiplication of small integers, 32-bit integers. This is like one of the simplest operations that is, available on all hardware today, CPUs, GPUs, like, 32-bit operations on integers. If you allow that, that would be even more amazing, right? You allow addition and multiplication, modulo some small prime. You allow verifying more directly hash chains, which again isn't a big, again, I'm talking to Bitcoin folks. So, right, dealing with hashes and verifying hashes is something that computers can do very efficiently. So there are like, I'd say two more things that if you allow them, you just get super efficient verification of Starks. And those two things are 32-bit addition and multiplication, modulo prime, and then allowing just basic verification of hash chains. So a very small amount of state. So with OPCAT, you could sort of go around that, but I think you're going in a very hacky, roundabout way at addressing a problem that Satoshi, I'm sure, would have approved you should just do in a more straightforward way. So I don't know. I like hope that the Bitcoin community does manage to get with all its conservatism, right? I'm not asking for like these very, very super risky things, right? I'm talking about addition of 32-bit integers, multiplication of 32-bit integers, and allowing a very minimal amount of state regarding a chain of hashes. It's really something that is very safe. That would really open the way to very, very big usage of Starks, very efficient one, hyperscaling, just having very good layer twos with all the social functions that you need implemented on Bitcoin safely.
Yeah, I guess it can take a decade until we get that sort of stuff on Bitcoin, which I guess is still fine, assuming
Yeah.
that there will not be some sort of competition to make Bitcoin obsolete and get more users on another network. But I think putting all of this stuff on a sidechain could be a very nice way to prove how the technology works.
I agree.
So,
I agree. And let me say this. I'll say, as CEO of StarkWare, I'll say, if there's a way to get our technology to integrate with Bitcoin, we would love to get it done, period. The only hesitation and the only reason that we are focusing on other things first is because those other places, Ethereum in particular, just very efficiently allows you to deploy any logic. So we went there. But like if Bitcoin allows us to deploy Stark verifiers, we will definitely, I mean, we have been already supporting nearly all of the research into putting Starks and SNARKs on Bitcoin. We've had a contribution to it, both through funding and discussions and so on. So you mentioned Robin Linus, the ZeroSync team. There's also QED, Chakra, BitVM, a bunch of other things. We're very supportive of all of them in both discussions, sharing of technology, and funding. Because, I'm a Stark Maxi. I would like to see it everywhere.
let me ask you this from a user experience point of view. How does this work? Because you get all of this cryptographic magic that's happening in the background, but from the perspective of a user who just clicks on a wallet, what does this look like?
So the best way to what it looks like is to try and download one of the Starknet wallets and just experience it, because you will be blown away by two things: the combination of security and good UX. And how does this come about? So on Starknet, because we have the ability to put a lot of computation, because again, all of the computation doesn't require anything on chain. It all goes off chain. And then you send like a very efficient, small footprint Stark proof to verify everything that happened. So Starknet has 100% account abstraction, which basically means that developers get to decide what is the method they want to secure their wallets with. So now, these two wallets who have spearheaded development on Starknet, namely Bravos and Argent. What they've done is they allowed you to use basically your biometrics from your smartphone, if you want, or from anything you trust, and use that to secure your keys. Now, you can also secure your keys in the more conventional way with, generating long passphrases and so on. But the ability of Starks to open up, unleash amounts of computation, also allow you to choose the best kind of cryptography that you want to secure your transactions and use that. So on Starknet, you can secure things the Bitcoin way with SecP signatures. You can also do it using Ethereum signatures, but you can also open a whole new host of ways to secure transactions. And again, by the way, this is something that's available only on Starknet. So Starknet is the only blockchain, to best of my knowledge, that has 100% account abstraction, which allows the teams deploying on it to pick the security method that their users find safest.
I was going to ask you, what's the difference between StarkWare and Starknet? I see that you presented both terms in your previous statement, and I don't think we spoke anything about what Starknet is.
Okay, so StarkWare is a company that I co-founded, 6 years ago, with Uri, who was the CEO up till 3 months ago, and he stepped down due to personal health reasons. I replaced him for the past 3 months or so. So StarkWare is a company. We have 170 employees, and we build basically two products. They are both of them layer 2s operating as validity rollups on top of Ethereum. And Starknet is the second of these two products. It's been out there, I think now for 2 years, maybe, or maybe a little bit more. And it's a general purpose Turing complete layer 2 on top of Ethereum, which means that anyone can permissionlessly deploy smart contracts. and anyone can submit transactions to, and it settles as a layer 2 onto Ethereum. It uses a new so StarkWare, the company, started a product which is a layer 2 called Starknet, which is a decentralized layer 2 using validity, using Stark proofs in order to scale Ethereum. And it can reach very high throughput and has a lot of other really beautiful aspects to it, like native account abstraction. It uses a very safe new language that StarkWare has developed. The language is called Cairo. It's Rust-inspired, ergonomic, safe, next generation smart contract language. And there's a lot of other interesting stuff going on Starknet.
Yeah, I very much look forward to StarkWare releasing StarkBit, which would be the Bitcoin version of it. I think that's exciting, and maybe it can happen just by enabling Opcode. Maybe we're gonna get that in the next couple of years, hopefully.
I hope that. I hope too.
So, is there anything that we haven't covered about what your product is doing?
Well, I guess like probably some of the listeners are asking, okay, what can I do to, like, suppose I'm interested in this and want to help. I'm a Bitcoin enthusiast, and I ask myself, other than listening to this, is there any way I can support or learn more? So I want to address that. And I think the one-liner is go look at Starknet and go look at Cairo. Cairo is the programming language which you use to write smart contracts in Starknet. Why am I saying this? There's a bunch of activities going on in Starknet that are related also to Bitcoin, but also to other aspects of, advancing Stark proofs and Stark-based validity proofs that people should look at. So we're now building the second generation prover that's going to be working with these very small integers, actually 31-bit integers over the Mersenne prime. And there's a bunch of research projects going on there that are very interesting. There's also a beautiful mathematical research paper related to this, on which the next generation prover is going to be built. The term is Circle Starks. And you know what? Later on, I'll put some links, and I'll send you some links for those who are interested to follow. We'll follow up with some links for people to look into. The other thing is that if there's a way to put Starks, as you mentioned, BitStark or StarkBit, or maybe a version of Starknet on Bitcoin, we will definitely pursue it, and I think will be one of the best places in which to build onto Bitcoin. So by learning the Cairo programming language and experimenting with smart contracts and with things like account abstraction, today you will be better poised for doing the same things on Bitcoin. Finally, I'll just say that I'm guessing that some of your listeners are also opening to developing on other layer ones, namely Ethereum. And those who are open to that certainly will find that Starknet is the best next generation environment for scaling Ethereum. So I hope I am not angering too many of the Bitcoin listeners, but I'm guessing some of them are not just Bitcoin maxis.
Did you consider sending out a job offer to Elizabeth Stark, the CEO of Lightning Labs, to work for Starknet?
I would love to have her immediately. I think it would, I highly revere what she's doing, and I think it would be a little bit maybe out of place for us to put a job description out there. But there is something nice about, like, I would say that it's in her name, right? That she should be exploring building on or using the Stark technology, and happy to talk to her. But I'm guessing she's pretty occupied with what she's doing. If she's open to offers, yeah, sure. Would love to extend one.
I mean, if she takes the job, she can say that she was born for it.
You know what? The same thing happened with Zuko, right? Zuko was the CEO of Zcash. And he was not born with the name Zuko. He changed his name, but many years before co-founding Zcash. So, back in the day, I said to him, look, Zuko, it's like it's sort of, it's in the stars that you have to be working on Zcash because your name is Zuko. So I would say by the same rationale, yes, Elizabeth Stark should work on Starks, and we'd be happy to collaborate.
Yeah, a lot of people thought that Zcash stands for Zuko Cash, right?
Um, eh, well, the name came from elsewhere and from it's like from zero cash, but yeah, so I don't think it stands for Zuko Cash, but I'm sure that like the fact that his name is Zuko does, give some extra. Well, when you interview him, you should ask him if Zcash stands for Zuko Cash.
Oh, I should interview him. I've been bugging him with messages and he said he's busy. But let me ask you this final question before we get to how can people follow the project. It seems like Starks are the end goal right now, something to which all projects aspire because they're
Yes.
scalable, they're lightweight, and they have a pretty good design. But do you think that there's anything out there that can be much better than this? Do you envision anything which surpasses this elegance in cryptography?
Well, making predictions about the future is always tricky, especially with regards to science. So there are some aspects that we provably know you cannot improve on. So, for instance, verification time of a Stark is polylogarithmic, and we can prove that you cannot improve this to better than reducing the exponent in the poly to 1, because so there are like some strict limits to it. We also know that in terms of proving time, so proving time is quasi-linear, and we know that you cannot have better than linear proving time. We also know that in terms of cryptographic assumptions, the only cryptographic assumption you need for an interactive version of a Stark is a collision-resistant hash function, and it's very hard to find a simpler, trustworthy, acceptable cryptographic assumption. So there are three aspects on which I think, well, not just think, but we can mathematically prove that you cannot improve significantly. Having said that, there's a lot of room for lower order optimizations, and things have been carried out. So, we ourselves came up with something called elliptic curve FFTs and elliptic curve Starks. They don't require any number theory, so they're not like the pairing-based SNARKs, but they do use the group structure of elliptic curves to basically open up Starks, efficient Starks over any finite field. And then after that came the Circle Stark paper that follows on these footsteps by the Polygon researcher Ulrich Habok and StarkWare's David Levitt and Shachar Papini. This is a paper that came out about a month ago, and it's another innovation that allows you to work over the super efficient Mersenne prime. There's beautiful work on binary fields. So the original ZK Stark paper I wrote, and the code was actually over a binary field. And now there's a re-emergence of binary fields through the beautiful work of the team that used to be called Utlevana and renamed to Irreducible, and with a system called Binius. So there are a lot of these super interesting low-level optimizations that involve a lot of beautiful theory to them, and I think we'll see more of that. Yeah.
Yeah, I think this is the perfect moment to end this because someone on Twitter just called us scammers at live stream, and it's funny. This space is just really funny. And I was
Yeah.
going to ask you, how can people follow the Starknet project and StarkWare and keep up with all of this avant-garde zero-knowledge proof systems?
So I think the simplest is to follow Starknet on Twitter. If you just want one thing, you can follow Starknet. So, call it strudel, at Starknet. You can also follow StarkWare by following at StarkWare LTD. That's the Twitter handle. If you follow these two, you'll pretty much be open to all of the news that comes out from StarkWare and about Starknet. And then there are a lot more resources that you can find by either going to starknet.org or going to starkware.co, which are the two websites of the Starknet ecosystem and of StarkWare.
Ellie, I want to thank you for your time and for explaining all of this avant-garde stuff. To my listeners, I think it's very novel, and I'm happy that I'm able to introduce this into the Bitcoin conversation. I'm not aware of many podcasters in Bitcoin who talk about this stuff, and it's my honor to be part of this. So thank you very much for your time.
Thank you, Vlad, and thank you to all the listeners who took the time to listen in.
Yeah, about 1,600 of them. And I also need to give a shout out to the sponsors: Wasabi Wallet, Layer 2 Labs, Sato Chip, and Hodling.ch. Thank you very much, and I'll